Happy Sunday. All right. So far, I know that it's coming into this section, but we're still unable to find. I'll give you an example. Okay. Everything started. Now we go to Firefox, add a note. Because it doesn't recognize the hash that was sent across, it goes through and it indexes. Sorry, I just saw some. It indexes many of the files that were coming across. You can see that we have vacant entry paths for canonicalized DBs. And this one is special. It doesn't have the salt on it. The others all have salts. So we process through F here. Then we get a DB mutation. We print that out. There's our file hash. And it says, hey, I couldn't find it. None. So DB changes 246. Let's see what it is looking for. I want to see a slightly less pretty version of that array. I want to see the file name hash as a number. DB mutation dot final salt. Hmm. Oh, it is a U64. Why was it printing that way then? Oh, that's the file name hash. Okay. Okay. Now, what is our file ID? All right, run it again. I'm going to pour some tea. Write failed. No such file. Oh, that's FlexiLogger for app. Interesting. I know it's wrong. App 2? Well, come back to that. All right. So we received none. Our salt starts with 814. We do not have one here. These, as you can see, are in ascending order. Let's print out what this one is. Here. Salt. File ID. Good. Path is what we used. Okay. And where's that T? Okay. Barring T. App 3. This time, no such file or directory. Wonder why. Fascinating. Let's see where we're going to Firefox. All right. Salt. 1616. And we're expecting a 1616. So we're not finding that one. Are these identical? Yes. Okay, those are identical. So why would it not be able to find it if we're adding it to the database? Unless we're later removing it from the database? Good. That worked. Okay. We recognized all the previous files, so our process kind of works so far, except for not finding. All right, so if we can't find that, why can't we find it? That file that returns a none. We see this already had file? I don't think so, because we index. So we do an index. That mutates everything. Then we try to get by file ID. That file ID is the one we're debugging, yes? I wonder if our file ID is somehow different. Oh, well, if the salt's the same, then the file name has to be different. That means the file name hashes that are being calculated by VFS are somehow different. Okay. I would like a prettier way to display this series of bytes. Here, what if we just do that? And, oh, you know what? We should definitely print that out here. This is what I did not want, just a bunch of numbers like that. It's one hash. And we should be printing out the other hash down here. Oh, we didn't. Hmm. I thought I made that change. Was it up before? 252. Okay, that's at the end. Registering wall into index. Oh, it's here. Oh, yes, I want this printout. Yeah, that okay, so they are different. Well, there's your problem. All right. So, what are we using to canonicalize these two things? Um, At this point, all we know is that the VFS has given us a hash, and we're expecting to find it. Okay. I thought that DB mutation basically had the function that we used. Path. Canonicalizes the path. Why would that be different? Right. Where's that used? Here. And we know this one's different. Oh, that's the definition. I wonder why it took me there. Doesn't seem like a valid place. Oh, because we were doing the main DB file, and the other one is the wall. Okay. Let's rethink this. Like this, we know that it's a database, right? However, because we have to have it consistent between both sides, perhaps perhaps we strip off the dash WAL, everything after that, at the end of the file. Okay. So wherever we're calling this, oh, that was weird. Here and here. At this location, we cannot use the SQLite functions. What do we do with path? Let's check the docs. Yeah, we could look at the extension. It's an owned path buff like self, but with the given extension. So essentially, we're replacing the extension. Okay. let's make the change. Let's start by actually not calling this function. So we'll use the normal ones. We're using the same thing on both sides. Do we need the main DB anywhere else? Why are we cloning it? Path.extension, fill match arms. Good. Own that there. So we'll have our own extension. And we'll replace the extension. Right? What was the other function? With extension. This isn't, of course, correct. I just want to get the new bits down. Okay. Make sure the branch works. Good. Okay. Now, what is our extension? This is an OS stir. Into OS string. As encoded bytes. Is asking. Yeah. This is essentially what we're going to do. Except we're going to look for a hyphen. Okay. Let's try it. Iter on that? Yeah. is for an element in an iterator, returning its index. That's not quite what I want. Actually, if this is bytes, wait, no, what kind of bytes is this? It's U8s. Binary search. I don't want a binary search for an element. I want to treat this. Hmm. We could window over it, but that just feels weird. Let's find. Yes, that's my question. Window. I was just thinking that. I don't like that. How about regex on bytes? Oh dear. Okay. Well, window it is then. I don't. Is that really the only way? Hmm. All right. As encoded bytes. So we have our bytes. Bytes dot windows. Size 4. Position. Ooh, we could use our position. Is that actually going to be better? No. I think this that the dash WAL will be closer to the front than the end. Hmm. I've talked myself out of that. So I think we'll keep most of our wall logs with salts removed. So there won't be the kind of standard trash that I have laying around here. Position. Predicate. Mm, um, PDA for value. Da-da-da. Can I compare? Yes. I mean, this won't work. I can't do that. Oh, right. I have to do B. There we go. Okay. So we have our window. We have our position. Position returns an option to a usize. Got it. So if we did not find it at all, we return path, a two-owned path. Otherwise, if we did find it, we want to strip that off. And with extension, now extension here could be a slice, right? ext, boom, 0 dot dot pause. One too many. Cannot index a value of type. Oh, really? It has encoded bytes. Encoded bytes? We can't. Oh, I need bytes. Bytes, bytes, bytes. There we go. The trait bound blah is not satisfied. Okay. Does that need to be a string then? S, where S is Azref Oester. Path, string, stir. Okay. We shouldn't do it that way. Oh, wait. Where was bytes again? From encoded bytes. No, come back. This one. I just want to come back using this. Okay. Man, I forgot my gloves today. It is cold out. I wonder what the temperature is. Checking, checking. Ooh. Yeah, that's cold. That's below 10. All right. So now we have that. Oh, VAL, that would not have worked. It needs to be WAL. Also, it needs to be lowercase. Hmm. Sure. Make ASCII lowercase. Do ASCII. Wait, what is this? Converts the string to its ASCII lowercase equivalent in place. Yeah, let's not change it. Temporary value dropped. Okay, yeah. Doesn't really matter, actually. We could do make ASCII lowercase. That'll mutate self. Oh, it doesn't return itself. Oh, it's shit. Hmm. Okay. Nope. To ASCII lowercase is the answer. So we have a shared ref here. Good. That might fix it. Okay. Again, check up. Man, Office does not like it. It does pretty well, but it's getting chilly in here today. Hey, Firefox. It found it. Look at that. Oh, happy day. Okay. Let's remove our debug sections. Okay. So we find the file, get the file. If we didn't know about it before, we search it out. File already indexed versus indexing files for mutations. So we have our files. And what do we do now? This is an actual file. It's a Tokyo file. Not Silva. Good morning. Happy Sunday. What am I doing? I'm building a website for my wife. And that begins with a SQLite replication system using a VFS written in Rust. So, in order to build a scalable, globally performant website for my wife, on the cheap, right? This needs to run very efficient. Am I full stack? I am, yeah. Welcome. I've been full stack since before full stack was a word. Or a phrase? You don't know if it's possible. But would I give my opinion about your portfolio? What kind of portfolio is it? I mean, it sounds like an ad. I'm sorry, we just get some weird people coming in here, if you know what I mean. You're full stack, but you're better at front end. Just want an opinion. Well, ping me on Discord. Let's see. I wouldn't. No. Just send the link on Discord. Okay. So yeah, and I'll take a look after my stream. Error handling we're not doing. That does return an error. Super error doesn't convert though. Oh, you said, well, I'm kind of busy at the moment. I did get the link. I mark that as unread. I'll take a look later. I am a little in the middle of something, you know. So we get the file. Okay, I guess. Well, you know, I appreciate you guys hanging out. Did I work with C or C++ before using Rust? Yes, both. C, long time ago. I did that for, goodness, a long time. Um, And then C++ around 2006. And loud and proud. Let's see. Over at YouTube says, "You're amazed at coding. You're a huge nerd and have been for a while. You're good at repairing electronics and following schematics, but coding is an art I cannot grasp." Coding, it is a bit art, a bit more art, much more art than electronics. I also look at it like learning a foreign language, right? You're going to be terrible at it when you start, but the longer you spend in it, the better you get, right? And the frequency at which you use it. I mean, it has a lot of analogs to yeah, spoken and written languages. Although, thankfully, we don't have to conjugate verbs. It's a good analogy. Well, thank you. Yeah, you'll often hear me say that on the stream. All right, let's fix the error bit. Um, Actually, I just want this to return error, and where this is called to handle the conversion. Oh, I can't because it's the mutation handler. We're returning a future, so it does need to be super error. Okay, so let's make sure super error can handle DB changes error. What do we have here? We have something from the database changes. This is from that future. What's private? Interesting. We need a width. There we go. Man, I like this baseline. Okay, so we receive a database mutation from, and this is here, what's happening. We send a notification that there's been a change at a position, right? A transaction has been committed to a wall log. That information is then transmitted over no, not a label there, stop it. That pipe. Data plane hears that. It's listening to that pipe. Data plane needs to pick up those changes, make them nice and pretty, and stream them over to data archive. data archive would then stream them to the rest of the network. Oh, I should have thumbs up that song. Can we go back? No. Boo. All right. Do I have a website or anything? Not really. Um, the cobbler's kids have no shoes and all that. Hey, now help me with the pronunciation of your alias here. Uh, I'm gonna butcher it first. S- Silbish, and welcome. What do you go by? Just let me know. I'll do my best to remember. So we get the file. Now we need to go find slab. Oh, perfect. We'll go with slab. Slab. So first, we find the file that the transaction happened in, or the mutation. Now that we have the file, we need to go to a specific place in the file. And I think at this point, we're likely to change from a Tokyo file into another structure because there's a little bit more information that we need from the file in order to keep this performant. And I wonder what the temperature is in my office. It is very freezing out. Very, very freezing. And the little old heater there just isn't keeping up. Oh, I was muted. Hmm. Did I say the bit about the snow? Anyhow, I like the way the snow looks when it's really, really cold. It has a different sparkle to it. Okay. Let's change our file. First, get UI. Let's at least get some of this staged. Uh, what is this? Oh, that's debugging stuff. And loud and proud. Do I have a website? I tend not to have a website. So I have I have a couple of domains. Um, roosterbuckets.com, right? As you can see, nothing. Um, then my full name, benjaminhalstead.com, which of course anybody could find if you looked me up on LinkedIn. Also gone. Um, talking to people in his head, yeah. I stream to both Twitch and YouTube. Uh, most of my work, yeah, it's been, I don't know, but you're right. You're right. Okay. Well, thank you for the feedback, loud and proud. I would like to have something. That'd be nice. Kind of a fancier, CV, if you will. Well, you know what? After I get this built, I can put my own website on it. Oh, I could do that. Hmm. Okay. So we have everything staged. Let's reload all. Good. Well, thank you for stopping in, loud and proud. Have a great Sunday. All files. Yeah, we're going to change this. So when we get a file, we're going to have a new structure, our wall file, wall log. Hmm. I like wall log better than wall file. Okay. So we have our wall log. Hmm. Voice is a little off today. Wall log, wall log, wall log. Inside of this, we want a file, Tokyo FS file. We also want something that's called iChange. Um, this is in the wall log. We want to keep it count ourselves. Let's generate a new. So the first thing we're going to do when we load a file is actually read the header. So we're going to grab that code from here. Here. We might have an error though. Okay, we'll need to handle that. Well, they pass in the file. Okay, we can do this. There we go. Wrong copy buffer. Oh, that has to be async on the new. Okay. We could delay this. No, I want a consistent. I don't want that. Let's have the header. Oh, we don't have the path. Hmm. We could move this in. Yeah, let's move that in. Oops. This will need to be an okay. So file in this case is going to be wall log new. We'll give it the path. Now, if there, oh, we have to await that. Okay. Now, in this case, we have a wall log, and we should be able to ask it for the salt. So we'll ask for that. Why don't we just put it here? Got that. Good. All right. Oh, we can't trace it though. Oh, fine. Yep, no function there yet. We'll get there. Okay. But does this make sense? We have a file. Okay. Error. We insert none. Okay, that should bubble up. Good. Generate salt method. Self dot header salt. Done. Same thing here. This file. Oh, just in front of it. How'd I miss that? Man, this cold has got me all tense. I'm going to adjust the desk. I'm going to stand up. Okay, there we go. Okay, so now we have our new type. Oh, we're not quite there. Get file. Yes, you're returning a wall log. Oh, wall log doesn't implement that. Fine. All right. So now that we have our wall log, as we read through it, seeking change by change, we will increment iChange. So if we get something that says, like file dot stream transaction, something like that, and we give it a position, then it has to go and read the file up to that position. I wonder if, like, what's better, buffered reader or memmap? Right? Memmap's always faster. Map blocks plus populate. Yeah, huge pages. Oh, I use ripgrep all the time. All the time. It's awesome. Anti pitch. Oh. So we should open that using memmap. Yeah, it's memmap. I mean, that's what it's designed for. Where did I use memmap before? Ooh, DB checksum. Yes. Mm-hmm. Fine. Yeah, we're going to be doing sequential as well. Oops. Let's go back to the code. All right. We open a file. Hmm. I wonder if it's going to matter if this is a Tokyo file. Oh, is this going to play nice with Tokyo? Is it going to block the threads? Slab. Uh, Also, you feel smarter when using memmap, so that's reason enough. Tokyo. Oh, okay. I was not expecting. FM map? What? What is this? Tokyo-based mmap file. Ooh. Design of this crate is inspired by dgraph's mmap file implementations in Stretto. What is Stretto? Okay, gone. File lock APIs. Interesting. What's the usage on this? Updated over a year ago. Any issues? Same. I'm contemplating just putting it into the blocking thread, right, for Tokyo. That seems like it would be enough for me. Are these just futures? What is this? Man, somebody spent a lot of time on this. Sync disk mapped file. Yeah, where's that? Declare. Okay. Somebody spent a lot of time on this. Yeah, open, freeze. Here we go. Open in. What is it doing? Create true. Where's like redimple? Maybe I'm thinking about this wrong. Let's go to this. You know, if I part of hyper mode. Hmm. Crawling out of that. Good our way. So we already have a DB file handle. Well, a file handle. It happens to be a wall log. That's fine though. But then we need a couple more structures. We need these bits. What was it? Memap 2. Adjust error. Standard IO error. Got it. Really? Of course. What was I thinking? Error. There we go. Okay. Now for this one. What do we get here? Is this also IO? Yes. IO error. All right, so then we mem map it and save that. And what is our mem map? It is a M map. Got it. All right, so we've loaded that up. No such field path. All right. I think we should also have some sort of position. Oh, you know what? We can use the memmap reading for this as well. We don't have to read exact, do we? Oh, yeah, we're going to need some sort of position, posy size. What else? We want page size. What is page size? I want to cache this. Looks like it's a U32. Okay. Subway dude, how are you? Welcome. Happy Sunday. I change. Okay. A little closer. Okay. Let's do this later after the map. It feels like the formatting is just broken in this file. What's going on? Oh, interesting. Thank you. Thank you, Rust Compiler, for catching that for me. Let's just change this. No, no, no. I like that better this way. Here we go. That's keeping it from formatting. Okay. Oh, much better. What am I using to do this? Let's see. I am on an OS 10 machine using Rust inside of Ghost TTY and Helix. I'm using the Helix editor. Helix editor has um, LSP support, so Rust Analyzer. Expected. Interesting. Good. Size is going to be equal to header dot page size. Rust Analyzer is kind of crazy. Agreed. It is amazing. It's even better in Visual Studio Code. Okay, now we have memmap working. Maybe. We'll try it. Okay, these are all never read. Let's file, map, I change and pause, and page size are never read. Wallach has a derive impl for the trait debug, but this is intentionally not. Okay, we'll get there. Yeah, I leave the things kind of online just so I see where they are, and then just have it expand when I focus on it, which seems to work pretty well. It helps. It actually helps me to move faster as I know where things are breaking. Doc Spins, how are you? Thank you for the follow. Okay, so now we have a file with all sorts of goodies in it. Um, Actually, we might have a file because that's an option. Oh, and we are handling errors. See, we now handle errors. So we need to get the next, um, the next transaction is. What can we do with memmap? There's no clone or debug or anything on it. Stable deref. They have debug. Okay. Azref, which is just cool. Okay. Let's close this. I don't know what I want it to look like now because we're going to say something like won't log. dot. And at this point, we actually needed to stream the mutation. Is the the mutation could be as large as the database itself or larger, right? Maybe there's a giant insert that somebody did in a transaction. So the pages in that commit, we will chunk them to the data archive server. So perhaps an iterator here. Just thinking through it. So we'll have to create an iterator for a section. Well, let's see how this goes. Transaction pages. I don't know what I want this to look. Do I actually need anything from the header at that point? It might. So wall logs. It's going to be over here somewhere. Wow. Index format. Header details. That's not what we want. This is for the top level, but we want the frames. This is for the wall index header. MX frame field. No, that's not it. This feels like the same. Is this the same? It is. Check some backfill. No, no. That's obviously not it. Let's go back. Database file format. Well, it had a, hold on, section here. Oh, interesting. Here it says the wall header format has a file. That version. Is that the same over here? Here, unused. Okay. No, this is for the index file, the shim. Okay, wrong one. Okay. Format, page size, checkpoint sequence number. Yeah, that's as it is checkpointing data back into the database, it stores how far it made it here. And then for each frame, right, this is the start of the file. And then after these 32 bytes, we have this over and over and over again. So we have the page number, commit records. So basically, you have this set to 0 until the end of the commit. Commit transaction. It's kind of the same thing. Transactions create commits in the wall log. So I kind of use the phrase interchangeably. Oh, yes, we should. Do we actually have to do this? I don't think I have to do this comparison. It's the reason that they say this is because they reuse a wall log, which means you might get to a point where there's data after where you are, but it's from the previous use of the file. Probably check it just for sanity's sake here. Okay. Now, immediately following the wall header are 0 or more frames. Each frame consists of 24-byte frame header, followed by a page size bytes of page data. There's our payload. The frame header is 6 big Indian 32-bit unsigned integer values. SQLite always tends to use big endian, except for when they know the data is not leaving the machine. Big endian. Endian. Here. It's the byte order in memory for which bit means like the highest value in the U32 and which bit means the smallest value, right? So when it's laid out in memory, does the small value come first or last in the value? Okay. Let's go ahead and check if the solve values are the same. Oh, you did the joke. Thank you, Slab. Well, some people might not have known, so it's good to go over. I don't actually remember which direction is Big Indian and Little Indian. I have rarely, rarely ever needed to do bit twiddling in order to, well, bit twiddling that ended up going on um, machines where I had to know. Anyhow, yeah. So let's keep this here. So we'll need the salt values. Salt 1 and 2. Let's call it salt. They're right next to each other in memory. Just gonna hold on to them together. Okay. I kind of feel like this should become some other type when I do this. Sold something, not sure what yet. Error. Oh, undo that. Undo, please. Thank you. So now we need to get our position up to that position. How do we want to do this? So we're currently at a position. We need to read 32 bytes. No, 24 bytes. Maybe we tell it to seek. Oh, I like that better. And then you just keep reading until you've found the end of the transaction. Let's try that. We'll seek to that position, right? If self.pose is greater than pose, return error on log seek error. I've never heard of Catus. Quite frankly, this feels like an ad. If you have Rust specific questions, please ask your question. Um, but I'm going to delete the ad. But feel free to ask your questions. I mean, just, oh, you're in first year programming? Have you gone through the Rust website? And so if you go to rustling.org, there's a learn link at the top. And there's a Rustlings course, which is really, really good. Just works you through learning Rust, getting set up. Yeah, welcome. No harm, no foul. We just get some weird things sometimes. You didn't know about Rust and thought I was playing the game Rust in between programming? Oh, no, no, I am programming in Rust using Rust. Not the game in any sense. So, but yeah, there are great, great, um, like programming exercise places I've used in the past. I really liked the exorcism.io courses, by the way. Um, I would highly recommend exorcism.io. Slav, yes, we're playing the Rust game, and Clippy always wins. Yeah, I don't know if you've ever seen it. Exorcism.io. This guy here. Highly recommend this. Elite Code, also pretty good. I actually like how they interact with the command line here. Um, and I love the community. It's been pretty good to me. I used this when I was first learning Rust. That I'm probably going to use it as I learn Go, as I need to learn Go as well. Um, and there's also a free code something, free code camp. Is that it? Whoa, that's very bright. Is this it? I think it is. I've also had people go through this with really good success. Back to my map. You've been using the Rustbook CS Brown. Yeah. Okay. Brown.edu. Fine. There's another one. The 3-day course that Google set up. Google Rust 3-day. Is it this one? I think it's this one. Comprehensive Rust. That's like pretty involved, but it's not 3 days. Looks like. Okay, day 4. Yeah, and then it just keeps going. Iterators. Yeah, you definitely want to get to day 4. Well, interesting. Learning how to develop macros. See chapter 19 and a half in the Rust book. You know what? Um, Detolne has a great uh, workshop that I would actually recommend more than the book for doing macros, proc macros specifically. So I went through this and then worked a lot on doing the GD native system for using Rust and Godot. Um, my contributions have since been archived because Godot version 4 has a different system, and yeah, they just completely redid the plugin. Anyhow, so what do we want in this? Let's see. Current self.pause, expected pause. Let's do something like that. Let's create, generate variant. Batman. The Godot plugin is a little silly. I don't know what it currently looks like. There are things that I was doing. I was generating meshes at runtime. Part of the API weirdness is how the the framework works, right? Godot itself, how it does GD native, at least when I was familiar with it. Okay, we got that. Mismatch types. Oh, this will be an error. All right, there's our error variant. So we're going to seek. Ooh, usize in a 32. Sure, U32. Why not? Really though? Why is that? I think I had the same sort of moment last time where I just thought, you know, why a U32? Like we might have a 4 gig wall log. That would be sad. Now I have to go verify that. Let's go here. So when we send that data, it's not there, it's in wall here. Here's our FIFO. We write this commit start. It's an I64? Oh, okay. That is messed up then. Oh, start pause is I64 there. That's my fault on the other side. Okay. Start pause, I64, seek. Yep. Now we have to update this. Okay. Mm-hmm. Yeah, that's going to be a pain. See, this is pointer sized. It might be 32, it might be 64. And I64 gives us 63 bits of. So we need it to definitely be not a 32. So we can't use usize. Do I think that looking up Rustling's GitHub repo for best practice a bad idea? You know, I would look at so Batman, great question. Hmm. I would look at some of the kind of uh, great examples in the community and see how they code. Right. Um, Detolne, look at his stuff. I don't know that. So if you come in here and you just find something, most downloaded. Let's go to Saturday. Okay. Click on this. We'll see. Anyhow, it's just a bunch of different stuff here. What else do we recognize? Used by contributors. And I would look at some of the top crates, especially people like this. There are others, of course. Um, I'm just blinking. Okay. Yeah, it's U size, but that might step it down. Oh, I'd rather use like a U30, U64. So if we do this, then we might lose some data. What else can we do with mmap? Mmap dot. Hmm. Oh, I need more tea. Zoc 2. Welcome, welcome, Raiders. How was your stream? All right. So, while we're streaming today, I can give you guys a little glimpse as to what we're working on. I am building a website for my wife. Okay. Now, how do you build a website for your wife? One could just start hacking on some HTML, maybe spin up some Node.js thingamabob, or you could take my route. I decided I was going to start it with some, I don't know, some tenets of the design. One that it had to run very light, very cheap, right? Needed to be able to scale though as well, right? So I thought, SQLite, why spin up a database? That's right, Zero. Right? Welcome to my website. You are on my website. Exactly. Just start, tossing some HTML out there. Maybe get some, Copilot or whatever to involve to just generate a lot of that for me. But no, no. We're doing SQLite replication so that it'd be fast for anybody around the world and it would be inexpensive, right? And then we won't just build a website, we'll build a website builder on top of this so that she can build the website herself using the tools I've provided. You love how overkill this looks? So, yeah. Now, we are currently working over here, right? When the proxy detects that a request is a mutation or will result in a mutation, it sends the request to, the writer, right? Not to one of the readers, but to a writer. And the writer then mutates the database. The VFS plugin that we've written detects the change, sends a notification to what we call data plane, which then shuffles the data off the machine to data archive, which then fans out the data to all the readers. Okay. So we've got most of this, I'd say 70 to 80% working. This piece here, from data plane on this side to this, is the missing link. So super light, and it's just SQLite. Tiny, fast, local. You don't have that time it takes to hop over the network to the like Postgres server or to Memcache or whatever you're using, right? SQLite has its own little memory caches. Yeah, just SQLite. That's right. And the great thing is, you can swap out the application. In one moment it's a website builder. Next moment, it's a forum. Whatever I want, and it all scales globally. Boom, done. So, building myself a website for my wife. Well, I'm building my wife a website. Shh. Did I say myself? Oh, goodness. Loud and Proud got me thinking about that earlier. They mentioned it on YouTube. Does it have a PC board extension? Oh, that's a great idea. All right. So remember, we're over here. SQLite has just told us about a change. So this is running Tokyo, pretty thin little wrapper, and we're mem mapping a file, trying to get to the change and send it over to data archive. All right. Now, expected a block. I don't know what I was doing there. Oh, that's right. I was mulling over the fact that that mem map here works with U sizes. I guess that's okay because if you're on a machine that is a 32-bit machine, you can only address a 4 GB file anyways. You can't read over 4 gigs, so that should be safe. Which means that we could actually use a U32 or a U size here, convert it here or before this. Let's deal with U size internally because that'll dictate, yeah, what we can actually look up. Okay. Good conversation. Thank you for walking through that with me. There we go. Okay. Self-up pause. Use size, page size. It's fine. As use size. Lovely. Oh, this is called seek now. Oh, on an option. Goodness. Fine. Yeah, what would we do if we couldn't find it? Scream loudly. Seek again or check again, I think is what we were thinking of doing. Because there is a chance that the file was renamed. It could have been the last transaction in a file, And SQLite decided to roll the file. Well, it doesn't roll. SQLite wants to reuse a file. We rotate it in our VFS. So we rotate the file, but before the message can get here, over the super fast named pipe, it's gone. So we can't find it. Or, yeah, we can't find it. Kind of seems silly. So what did we do? Hold on, let's check VFS. How did we rename that? It's not here. It's in VFS file. Open. Here's rotate. File. Set file name. We just rename it. So it's always going to exist on disk. There was a talk to bug somewhere we needed to be careful of. Okay. Yes. Yes, I remember now. Okay. Basically, I want to retry this if it's 0 or if it's none. Because this indexes a number of files and there's an amount of time that could have passed. However, it would not have changed again. So we can simply run this again if it can't find it. So if we did find it, we'll pass it through. Otherwise, we're just going to do that again. One more time, with feeling. But if the second time it is none, then we need to scream. Match that. Oh, why not? One more time. This is gross. So if we didn't find it the second time, we cry loudly, panic, all that. Um, you found out that your terminal emulator uses 300 megs of RAM per instance. Wow. I don't even want to look. Okay. I'm looking. Let's see. Let's see. Ghost TTY is using 255. All right. this here. Man, kind of feel like this should cry loudly. Part of the design that I have trouble with is is between here and here. If a mutation happens, right, it lands on the database. We get notified. However, if for some reason we can't find the change, what do we do? Or if we can't load a file, read a file, right, we can't get the change off disk, but the application could have already responded. I'm, I think the best I can do is signal to restart the writer, which would basically find all of the changes in the database and send them. So it's a little bit of a fragile spot. I'll have to think more about that. But while we think about that, let's just have tracing error. Could not find um, commit or transaction that DB mutation referenced. DB mutation. We skip it for now. I really don't like that. All right. So at this point, it should exist on disk, which is why we return the wall log itself. It needs to be mutable. Now it's mutable. It's behind a shared reference. Not borrow wall log as mutable. There we go. All right. So we seek to a location, and then we start reading these. Now, what does seek return? An error or a unit if everything was okay? That seems reasonable. with context. You know what? Let's not do this here. I get tired of putting with context on these things. They're all the same. There we go. So much better. Okay. Now we can just read the next piece out. Right? So we tell it to seek to this location. And what do we do next? Oh, entropy. Console's only using 56 megs on one, 46 on the other. Nice. Okay. Now let's look at the SQLite dogs yet again. Not that one. This one. So we could just have it read a frame. And it could send the frame or do whatever it wanted. Yeah, why not just do one at a time? We have to do a couple of checksum bits as well. Hmm, I don't know. So part of me, all right. So part of me wants to just send the data, right? Why wouldn't we just send the data? And then we have data archive deal with it. The other part of me says, oh, do this on the mutation server so that what? What am I trying to argue here? I'm trying to argue for correctness, right, of the data, consistency of the data. All right. Yeah. No. We're just going to do it here. While log while because we don't know when it's going to stop. Eventually, we'll break, right? Read frame. Do we need to give it anything? No, we don't. Let frame equals that. We're going to want to return some extra bits of info here. Page number, salt, some bits I'm not touching. That's a SQLite piece. Okay. We have our own checksums. So we have salt, the page number, commit records. We will need that, the salt, but not these. Okay. Do we want another data structure for this? Maybe. Hmm. Is that what it was called? Wolframe. Hmm. Header. Will format. Frame header. We already have that. Data. If we're going to return a reference to some mapped data. Fancy. I wonder. Does this even work though? Kind of not. Okay. So at this point, we are hopefully at that location, which we didn't bother getting to yet. Hmm. Okay, let's go fill that in real quick. We will have to use read frame ourselves. Huh. Fancy. Fine. Read frame. We want to read the first 24 bytes into the header. Something like so. Header is going to be equal to all format frame header new self the mem map, and this will be there's our header data. That is so. I'm concerned that this operation here, these self.mem maps, are going to be blocking. Right? Same with the ones up here. Like this one, fine. We could work around that. Right? Happens once. It's at the beginning of a file. Although, there's a cost there. I just don't want to wait for that. Why don't we just do that? Tokyo. Spawn blocking? Where is it? Tokyo. Docs.rs. Tokyo. Spawn blocking. Tokyo task spawn blocking. Okay. Dedicate. Let's see. This function runs the provided closure on a thread dedicated to blocking operations. Copy aborted. Now, at which level would we use spawn blocking? Here, of course. Tokyo task. Almost. So close. Spawn blocking. Now the task here doesn't do anything async. When handle, which we await. With context. What do we call this? This is locking join snafu. Something like that. I don't know where that is. Snafu display. When handle. Future joiner is where Tokyo task joiner. So close. Okay. Oh, we were here. Blocking join snafu. Funny. Can I find where? Blocking join error. Moved variable. Yes. Oh. Oh, this isn't going to be nice. This will happen all the time. Might be time to try that other crate out with the async bits. first. Let's check and see. This doesn't have async, does it? Does not look like it. Okay. Yeah, I think we're really close though. We just have this. Maybe we can just borrow it. Yeah. No, it doesn't outlive it though. Oh, but the reference here. No, that just copies the data out. Maybe we haven't finished with header. Header is a file header, which has its own data. Hey, Neanderthal. Neanderthal? Goodness. Neanderthal. What language do I mainly use at work? I don't talk about work while streaming. We have an agreement, and I can stream as long as I don't talk about work. So, yeah. The music is fitting. Yeah. Just curious if I use Rust also. Hmm. Yep. Well, thank you. Yeah. No harm, no foul. It's all good. Now, how do we fix this? Borrow occurs due to use in closure. Closure may outlive the current function, but it borrows memmap, which is owned by the current function. Mm-hmm. Is there another? Where's Tokyo here? Block on. Runs a future to completion. Okay. This doesn't have it in the blocking thread though. Yeah. going to have to be send anyways. Oh, this just isn't going to work. No. Maybe this is okay. Or maybe we should set this up as its own thread. If it was its own thread, we'd have no issue here. So we could just block. But because we are trying to integrate with the rest of data plane, it's a little bit of an issue. So what would happen here is that, or rather up here, we would end up blocking and sending. So we'd have these times of seeking or reading that that the other threads would be blocked on, or rather the other tasks would be blocked on. Which is why I was so curious about that other async was it? Where'd it go? No, now we're looking at I think yesterday's stuff. Oh, what is this? This is interesting. Just spawn a thread, do the work, await it. What does that look like? Functions. Insert task, fn once. Hmm. How is this different from the Tokyo one? It's the same thing. Here. Okay, here we are. Rubio. Man, it's cool. We want Tokyo. Where's the music? Switch it for a little bit. Ooh. That might be a little too hard. Let's try that. Yeah, what are the options? Mode, custom flags. How do we tell it that we want to advise? Okay. Get a self back. Get one of these. returns one of those, which doesn't exist. Okay. This is really not what I want. But we could do this, right? But I don't know. It just doesn't thrill me. I like the other interface better. I want to give it a range. And I want it to be quick. All right. Let's do this some other way. Getting rid of that. Okay. DB changes. Here we go. So we could pass this in and then get it back out. That's one way of doing it. We could have some sort of function that does this for us. Maybe wrapping memo. Getting a reference from something generated inside of a future is kind of sketchy, though, or something that's going to be done on another thread. Yeah, let's just wrap this struct. I don't know. Async memmap. Reader. What? Hmm. I want to see that. Where is that? Let's go back to my map. Tokyo blocking. Advise range. Interesting. Methods. I think we could make it work. Locks the whole memory map into RAM. Hmm. I don't think I care. Nightly. Is all of this just nightly? Nightly. Hmm. That's interesting. But where does it start? Oh, that's over the slice. Got it. Got it. Got it. Okay. I need to change this. I don't want to be going back and forth between threads, right? Little messages back and forth constantly. Not for this piece. I wonder. I think I can make this just work with a thread. Let's break it. Okay. Mutation. Well, files. Okay. Mutation handler. No. Let's say we did standard thread spawn. We just spawn a thread. Okay. In which case, let's say we could set something up here. We could communicate with channels still. Right. We have this Tokyo MPSC receiver, which will move through. Okay, something like so. This is not async. I get it. I don't care yet. Now, we want to join this. Ah, this needs to be a Tokyo red spawn. Does I know Tokyo has stuff for this. Runtime. No, no, no. Hmm. We build a new runtime. Maybe. But I know I need to spawn a thread, and I want to await the thread using Tokyo. Is it in Tokyo util? I guess we could do a spawn blocking with that, but that's just going to be there forever. I don't want that either. I thought they had like a stuff for that. I remember reading something about that. Feature flags. Tokyo process. Oh, am I thinking about that? Ew. I don't want to start a process. No. Mhm. Somebody must have a wrapper for this already. IO thread pool blocking. First functionality. First I need. Okay. Then we will do this slightly different. Tokyo. Task. No, Tokyo sync. One shot. Okay. We'll move the TX. We'll await the RX. Okay. Unexpected token. Yeah, I get it. Expected function. Oh, is that that's a module? Channel. This is not async. Got it. Inside of here, we'll have our new Tokyo. Single threaded variant. Tokyo. Runtime. Builder. New current thread. Thread name. All change. Why not? Same as the module. Um, Set up mutation thread. Set up mutation. Handle that later. On future. Async closures are unstable. Oh, just an async. Uh, Standard IO error. Interesting. That should not be super error. I guess it could be. We could change this later. Oh, it's a one shot. Yes. Sorry, my mistake. I was thinking. I just got confused. Okay. So receiver itself might receive an error. I don't know why. Maybe if it panics and whines, it drops. No, something, I'm not sure. Mismatch resolving. One shot results of. Okay. Oh, receiver. Thank you. Thank you. Oh, interesting. That can be done outside of asynchronous context. Got it. Future receiver. So we spawn a thread, set up a mutation, set up a thread, set up a runtime on the thread. We'll have to change that with context. DB mutation, runtime snafu. Okay, runtime. That's not what I wanted. Oh, source. What's our errors? Who knows? Snafu display. Not create runtime. Not create runtime. For db change thread. Entered IO result? Really? Okay. So we set up our thread, we set up our runtime, we block on this. That should just return. All right. So now we're in a single threaded runtime that we can block all we want on. Much better. Now sending data back and forth between these things. We'll just receive data from another thread here. Now, there is a little gotcha in that the db checksum needs to be passed through as well. Right? We need to be able to share some state with the rest of the app, and that's in the data db checksum thing. But for that, I believe we are using a dash map. And with our dash map, I believe we can share it between threads. Send and sync. Yay. All right. Lovely. We'll get to that eventually. Let's put a little love note here, though. Fix me. What about the dash db checksum? Dash. Okay. Now, none of this. So now we just block the thread. We're happy. We're good. Another question. Does it need to have a Tokyo runtime? I don't think it does. Why don't we just strip out all async? Okay, let's look and see what would happen first. Okay, that flattens out. A dash map. I don't think we have. This thing's fine. Our mutation receiver. Let's check the MPSC receiver. Tokyo. Oh, that's util. So we have our unbounded receiver. Blocking receive. Oh, lovely. Okay. Yeah, let's do it. Forget setting up this receiver. When this is finished, this doesn't need async. We just send it back. Good. Okay, set up mutation thread. I think this is going to basically just collapse into this here. That just goes away. There we go. It's not async. That's right. Blocking receive. That gives us an option, just like before. All log get file. No more async. Index files. No more async. Mismatch types, that's fine. Let's change the type to standard. Okay. Huh. Interesting. Was that it? No, here's some. Get file. It's not await anymore. Okay. Okay. Lovely. Get rid of that. I don't even know why that's there. Okay. All log. No awaiting that now. Okay. Read frame. Yeah. That should be returning a result. Too many vocals. All right. Now, again, you know, anything else past that? Hmm, okay. So now we're in a thread being driven by some channel that's passed into us. We don't have to worry about moving data around between threads. Okay. Now, what are we doing here? End is usize, self.page size. It's U32. Hmm. All right. Now, data in this case is a slice of self that header and data. Something wrong with that, though. What is it? Oh, we didn't update the end. Self dot pause equals end. Really like the pattern here. I'll leave it for now. Okay. Nothing like that. All right, so now we read frame. Now, where were we doing that? Loop. We have a frame. Okay. Let's add something to it. Well, frame. Let's impl that. Generate impl. That's not what it's called. Let's check. By record. The DB pages. Yeah, DB pages. All right. This is pretty good for the moment. Need to update the database checksums. So DB checksum knows where it is. That's useful in case this becomes a reader. Because if the writer becomes a reader, then it needs to know what the state of its databases are. I'm half tempted to actually split this. Now, let's leave it. We need to update iChange. Where does that happen? If we read a frame and the frame is a commit record, then we should increment the value. Okay, but I think that's it for me today. I'm gonna get going. Thank y'all for hanging out. I appreciate it. This is getting closer. We almost have data moving end to end. Almost. And once we get that happening, there are going to be problems. We'll have to dig in and fix them. It'll be great. We're going to raid Team Vosh again. All right. Well, I'm going to go find someplace warm to be. Oh, I can hear myself. All right, y'all. Take care. Bye bye.